This is lesson 10-3, areas of regular polygons. A regular polygon is a polygon that has all sides congruent. So we have this polygon over here, we have this hexagon because it has 6 sides. The radius of a regular polygon, the radius is the distance from the center to a vertex. So you see this blue line right here, that's the radius of this polygon. So it's the distance from the center to the vertex of the polygon. So there's actually more than one radius. From every center to every vertex is a radius. So I have 6 radiuses that are going on, so it actually can divide this polygon into 6 sections. All right, another important word that I'm going to be using for my formula to find the area is called the apothem. The apothem is this red line right here. The apothem is the perpendicular distance from a center to a side. Okay, the apothem is the perpendicular distance from the center to the side of the polygon. And the radius was the distance from the center to the vertex. The radiuses formed isosceles triangles, and then this apothem is actually making a right triangle. So we're going to use all that in our knowledge of triangles when we're finding out stuff. Before we get into the area, let's just talk about finding an angle measure. So the figure at the left is a regular pentagon with the radii and an apothem drawn. Now the radii are from the center to the vertex, so those are the blue lines. And then I have one apothem drawn, this red line right here. I want to find the measure of each numbered angle. So the first thing I want to find is angle 1 right here. Think about a full circle. A full circle is 360 degrees. Well, the radii have now divided this pentagon into 5 sections. So if I take 360 and I divide it by 5, that gives me the angle measure for angle 1 and for each of these sections right here. Okay, so 360 divided by 5 gives me 72. That's angle 1. So angle 1, if you ever want to find the angle right here where all the radii meet, okay, you just take 360 divided by how many sides the polygon has will give me angle 1. Now the red line is the apothem. The apothem just took one of these sections, one of these isosceles triangles, and it divided it in half. So the measure of angle 2 is going to be half of what angle 1 was. Okay, the apothem was a line from the vertex perpendicular to the side. So angle 2 is going to be half of the measure of angle 1. So angle 2 is just half of 72 degrees, which is 36 degrees, which I have here somewhere. All right. You guys can just write 36. All right, so angle 2 is 36 degrees. Now angle 3, now that I know angle 1 is 36 degrees, I know that this is a right angle, and this angle 3 is part of this right triangle right here, which is half of the, the blue lines. The apothem now has divided this into 2 smaller triangles, with this side being a right triangle. So this is 90, this is 36. You're going to add those together. Plus angle 3, together they equal 180. So angle 3 is 90 plus 36 plus the measure of angle 3 equals 180. So I can add the 90 and 36 and just subtract from 180. And that will be angle 3. Okay, and you guys can figure that out. An important postulate, if 2 figures are congruent, then their areas are equal. Sorry, if 2 figures are congruent, then their areas are equal. So these triangles right here are actually congruent. They're going to have equal areas as well. Okay, if 2 figures are congruent, then their areas are equal. So how do I find the area of a regular polygon? It equals half the product of the apothem and the perimeter. It equals half the product of the apothem and the perimeter. And I write that as area equals 1/2 AP. It's 1/2 the product of the apothem and the perimeter. Why does that actually work? Remember my radiuses? Okay, the radii divide these into isosceles triangles, and the triangles have equal areas. So all you're doing is you're finding the area of each of these isosceles triangles, however many that you have, like the hexagon in the original picture, I have 6, so I could just find the area of one of the triangles and times it by 6, or this pentagon has 5 isosceles triangles. I can find the area of one of them and times it by 6. But a little bit shorter, if I just add the perimeter of this figure and times it by 1/2 the apothem, which is the height of the isosceles triangle, then that's a little bit quicker. Okay, so it works because I have regular polygons and the radii dividing them into isosceles triangles, and those triangles have equal areas. So let's find the area of this regular decagon. A decagon has 10 sides. So first I'm going to find my perimeter. The perimeter is n times the sides. So it's 10 because I have 10 sides, and each side has a length of 8. Remember, this is a regular decagon, so all the sides are congruent to each other. So 10 times 8 is 80, so that's my perimeter. Now the area of a regular decagon is 1/2 AP. A is the apothem, so the apothem is this line right here. It's from the vertex perpendicular to the side, so my apothem is 12.3. So 1/2, 12.3 times the perimeter, which is 80. And that gives me 492. And that would be inches squared. Okay, so that's how I use my formula. That's the easy, basic way that I use it. Now it does get a little bit more complicated when I have when I don't have all of my measurements, but I'm going to use my knowledge of special triangles to actually find the area. So let's look at this example right here. A honeycomb is made up of regular hexagonal cells. The length of a side of a cell is 3 millimeters. What's the area of a cell? Now remember, my area is 1/2 AP. I don't have A. I don't have the apothem. I do have the side. The side is 3. Okay? And I know that this is a hexagon, so I'm dividing it into 6 isosceles triangles, and these angles are 60 right here. So this little section has an angle of 60, and remember the apothem then cuts that in half, so this is actually 30. I don't have the apothem, but I can figure it out because this is actually a 30, 60, 90 triangle. So the whole edge was 3, and now this apothem, which I don't have yet, is cutting that in half, so this little section is 1.5. So remember my 30, 60, 90 rule. The longer leg, which is the leg opposite the 60 degrees, okay, is radical 3 times the shorter leg. So this is 30. Remember, the apothem divided in half, so this is 30, this is 60. This is 30. Across from the 30 is 1.5, because the whole thing used to be 3. And now this is 60, so across from the 60, this is radical 3 times 1.5. So it's 1.5 radical 3. So that's my apothem. So these are more complicated in that sometimes you have to figure out the apothem. Okay, so it's 1.5 radical 3. So now my perimeter is the number of sides times the length of the side. So remember, I had 6 sides. It was a hexagon. Each edge is 3, so 6 times 3 is 18. All right, and then my final area is 1/2 the apothem times the perimeter. So the apothem was 1.5 radical 3, and my perimeter was 18. So it's 1/2, 1.5 radical 3 times 18, and I'm just doing this in the calculator, so it's not a big deal that I have this radical 3 in there, and it's approximately 23.38. And you might be asked to leave it as a radical, you might be asked to round it to the nearest tenth or the nearest whole number, but that's how it's done. Okay, and that's it.